11th Science, Chapter 8, Redox Reactions, Part 3, Balancing Redox Reaction by Ion Exchange Method. Hello students, I am Madhusina, your chemistry teacher. Watch my YouTube videos, like and subscribe it for further notification. In this video, we will discuss about the rules for balancing redox reaction by ion exchange method, which is also known as half reaction method. So we will first understand the rules and then we will understand this concept with the help of some examples. Rules for balancing redox reaction by ion exchange method. First rule says that write down the skeletal equation. Write down the oxidation number of all the elements and identify the species getting oxidized as well as reduced. Split the whole reaction into two half equations. Now balance all the other atoms except hydrogen and oxygen in both half cells. Balance oxygen and hydrogen depending upon the medium of the reaction. For acidic medium, balance oxygen by adding water molecules on the deficient side. Balance hydrogen by adding H plus ions on the deficient side. For basic medium, balance oxygen by adding required number of water molecules on the side where oxygen is more and add double the number of OH minus ions on the other side. For balancing hydrogen, add OH minus on the other side where hydrogen is more and add same number of water molecules on the other side. Now balance the ionic charges on either side by adding electrons. Multiply one or both sides of the half equation with a suitable factor so that electrons are balanced. Now add the two balanced half equations to get the overall reaction. So students, after going through the rules, now let us do the question of balancing, and first of all we will do it in the acidic medium. Consider this example. MnO4 minus plus Fe plus 2 gives Mn plus 2 plus Fe plus 3. Now this redox reaction we are going to balance by ion exchange method, which is also known as half reaction method. Now first of all, what are we going to do? We have already written down the skeletal equation. Then as usual, put down the oxidation numbers. Minus 2 plus 7. You can calculate, you know how to calculate the oxidation numbers. Plus 2 and plus 3. Connect the elements which are undergoing change in oxidation number. So what is happening here? Here plus 7 is getting converted into 2. That means there is decrease in oxidation number and that process is called as reduction. Plus 2 is changing into plus 3. That means here the process of oxidation is taking place. Now in half reaction method, what is the next step? We have to write these reduced and oxidized reactions separately. So I am directly putting step number 1 and I am writing the oxidized half cell first of all, and my oxidized half cell I will write a bit smaller so that oxidized half cell. So which is my oxidized half cell? Fe plus 2 is changing into Fe plus 3 and my reduced half cell is, or reduction half cell is, MnO4 minus is changing into Mn plus 2. Now in step number 2, what are we going to do? In step number 2, you are going to balance all other atoms except hydrogen and oxygen. So, in step 2, balance all other atoms. Now, here 1 Fe, 1 Fe, 1 Ma, 1 Ma. That means it is already balanced. We don't need to balance. I am just putting it again. Gives Fe plus 3 and MnO4 minus gives Mn plus 2. Now in step number 3, we are supposed to balance oxygen and hydrogen. Now remember the rules very clearly. We are balancing by ion exchange method. In this, balancing of oxygen is done by adding water molecules on the deficient side, and balancing of hydrogen is done by adding H plus ions on the deficient side. So let us see here. So we will first of all write balance oxygen and hydrogen. Now medium is acidic. Very important, you have to check the medium. We don't have any hydrogen oxygen here, so we are simply going to write Fe plus 2 gives Fe plus 3. And here we are having 4 oxygen on this side. We don't have any oxygen on this side. So we have to add 4 water molecules on this side. So I am putting MnO4 minus gives Mn plus 2 plus 4H2O. Now since we have balanced oxygen, but now hydrogen is not balanced. So check hydrogen. 4 2s are 8. Now this side, so we will put 8H plus on this side. Now in step number 4. Step 4. We have to balance the ionic charges. Balance ionic charges. Now, in half reaction method, we don't have to add H plus or OH minus ions to balance the charges. We have to balance the ionic charges by adding electrons. Now, let us see. Fe plus 2, here it is plus 2 charge. And in this case, it is plus 3. So, how will you make plus 2 equal to plus 3? If I put one electron here, then on both the sides the charges will become plus 3. So, Fe plus 2 gives Fe plus 3 plus electron. So, the charge is balanced here. Now, here you see 1 negative charge and 8 positive. So, minus 1 plus 8. That means here we are having plus 7 charge on this side, and on this side I am having plus 2 charge. How will you make plus 7 equal to plus 2? If I put 5 electrons here, electron is having negative charge, minus 5, then both sides the charges are going to become same. So I am going to put 5 electrons, MnO4 minus plus 8H plus 5 electrons is going to give Mn plus 2 plus 4H2O. Now the charges are balanced in both the equation. Now in step number 4, what are we supposed to do? You have to cancel these electrons, and for that purpose you need to balance the electrons. Now you can see here we are having 5 electrons and here we are having 1 electron. So So if I multiply this by 5, then in both the cases, the electrons are going to become same. But if you are multiplying by 5, you have to multiply everything by 5. So let us move on. I am rubbing the upper portion so that it is clear. So in step 5, I will rewrite it by multiplying. So 5 Fe plus 2 gives 5 Fe plus 3 plus 5 electrons, and the other reaction is MnO4 minus plus 8H plus 5 electron gives Mn plus 2 plus 4H2O. Okay. Now, what are you supposed to do? Finally, you have to add the two balanced half equation to get your answer. Now you can see on both the sides of the arrow. Right? Let me put it in a proper manner so that you can easily understand. I'll put the arrow here in the center so that the things are very clear. Here I am having Mn plus 2 plus 4H2O, and here we are having Fe plus 3 plus 5 electrons, Fe plus 2. So 5 Fe plus 2 and 5. Here Fe plus 3, and this side we are having MnO4 minus plus 8H plus 5 electrons. Now you can see on left hand side and right hand side we are having 5 electrons, which is going to get cancelled. Now add both the half reactions, and that is your answer. So you are going to have 5 Fe plus 2 plus MnO4 minus plus 8H plus gives 5 Fe plus 3 plus Mn plus 2 plus 4H2O, and this is your balanced equation. So we have to follow. First you have to put down oxidation number, then you have to write down both the oxidized half cell and reduced half cell separately. In the next step, what are we supposed to do? After writing, we have to balance all the other atoms except hydrogen and oxygen. Then you balance hydrogen and oxygen. Since it is an acidic medium, oxygen is balanced by adding water molecule on the deficient side, and hydrogen is balanced by adding H plus ions on the deficient side. After balancing hydrogen and oxygen, balance the ionic charges by putting electrons, and then you have to balance the electrons in both the reaction by multiplying with a suitable coefficient. Finally, you have to add down both the half reactions. So the electrons will get cancelled from both the sides, and you will get your balanced redox reaction by half reaction method, which is also known as ion exchange method. So students, after learning how to balance the redox reaction in acidic medium by ion exchange method, let us go on to the basic medium. So in the first step, a skeletal equation is written. We have written down the oxidation number of all the elements involved in the reaction. You split the reaction into the oxidized half cell and reduced half cell in step number 1. So this is Fe plus 2 is undergoing oxidation into this is our oxidized half cell, and NO3 minus is getting reduced to NH4 plus. So this is our reduced half cell. So in step number 1, we are going to split the reaction into 2 half cells. In step number 2, we will balance all the other atoms except hydrogen and oxygen. 1 Fe, 1 Fe, 1 nitrogen, 1 nitrogen. That means they are already balanced. In case they are not balanced, then we will balance it by adding a suitable coefficient, by multiplying by a suitable coefficient. Now, very important step. Balancing oxygen and hydrogen. Now the medium is basic. You have to check the medium. Now for basic medium, oxygen is balanced by adding water molecules on the side where oxygen is more and double the number of OH minus ions on the other side. Listen carefully. Now let us see. Here we don't have any oxygen, so we are going to put down the reaction as it is. Right? Now we will balance oxygen. So first of all, balancing oxygen. NO3 minus changes into NH4 plus. Now for balancing oxygen, see on this side we are having 3 oxygen. There is no oxygen on this side. So this side oxygen is more, and how many more? 3 oxygen more. So we will put 3 water molecules on this side and double the number of OH minus ions on this side. So double the number of OH minus ion means 6 OH minus ion on this side. So 3 oxygen was more here. This side there was no oxygen. So same number of water molecules on the side where oxygen is more and double the number of OH minus ions on the other side. Now we have balanced oxygen. Let us check. 3 and 3, 6, and here 6. So oxygen is balanced. Now we need to balance hydrogen. Hydrogen is balanced by adding OH minus ions on the side where there is more hydrogen and same number of water molecule on the other side. Now I will balance hydrogen. See carefully. Check. Here in this reaction we don't have any hydrogen or oxygen involved. Now here 3 2s are 6 hydrogen here, and we are going to have 4 and 6. 10 hydrogen is there on this side. On right hand side we are having 10 hydrogen. On left hand side we are having 6 hydrogen. So which side is more hydrogen? Right hand side more hydrogen. How many more hydrogen is there on the right hand side? 4 hydrogen is more on right hand side. So what we will do? We are going to add 4 OH minus. I have to add 4 OH minus on the side where there is more hydrogen and same number of water molecule on the other side. So now this reaction is going to become like this. NO3 minus plus 3 and 4, 7H2O gives NH4 plus 6 and 4, 10 OH minus. So my one reaction is this and the other one is this. Now after balancing hydrogen and oxygen, we have to balance the ionic charges. So first of all, let us go for balancing ionic charges. So step number 4. Balance ionic charges. And how we are going to balance ionic charges? By adding electrons. Now you can see Fe plus 2 gives Fe plus 3. So on left hand side plus 2 is the charge, on right hand side plus 3. So how can you make it equal? If I add 1 electron on this side, now 3 minus 1 will become plus 2 and this side also plus 2. So the charges are balanced. Now let us see for the next one. NO3 minus plus 7H2O gives we will put the arrows properly so that while adding we don't have any problem in understanding. NH4 plus 10 OH minus. Now let us check the charges on this side. 1 minus 1 is the charge here, and here plus 1 plus 10 minus charge. That means plus 1 minus 10. So that is going to become minus 9 charge, and this side we are having minus 1. That means if I add 8 electrons on this side, then both sides it will become minus 9. So I am going to add 8 electrons here. So the charges are balanced now. Now you can see what is the next step. Next step says that you have to make the number of electrons equal by multiplying with the suitable coefficient. Here 8 electrons, here 1 electron. So what will we do? We will multiply this equation by 8 and we will go for step number 5, where we are writing Fe plus 2 gives 8. You have to multiply. So 8 Fe plus 2 gives 8 Fe plus 3 plus 8 electrons. Now let us go for the next reaction. NO3 minus plus 7H2O plus 8 electron gives NH4 plus 10 OH minus. Now what are we supposed to do in the next one? In the next step we are supposed to add both the reactions. So while adding, this will get cancelled and your answer will be 8 Fe plus 2 plus NO3 minus plus 7H2O gives 8 Fe plus 3 plus NH4 plus 10 OH minus, and this is your balanced redox reaction. So what are you supposed to do? You have to first of all split it into oxidized and reduced form. Then you have to balance all the other atoms except hydrogen and oxygen. After that, balance hydrogen and oxygen, and since the medium is basic, for balancing oxygen, add water molecules on the side where oxygen is more and double the number of OH minus ions on the other side. And for balancing hydrogen in basic medium, add OH minus ions on the side where hydrogen is more and same number of water molecules on the other side. Then you balance the ionic charges by putting electrons, balance the electrons, and then finally add both the half reactions to get a balanced redox reaction by ionic exchange method.
Let's revisit the redox reaction that we've seen. Here, we place a zinc rod in copper nitrate solution. After a while, the color of the solution becomes pale blue, and finally, it becomes colorless. The zinc rod, on the other hand, gets coated with reddish metallic copper. In this reaction, zinc is oxidized to zinc ions and copper 2 plus ions are reduced to form copper. This reaction took place in an open vessel, and the chemical energy from the reaction was released as heat. Think about it. Is it possible to convert the chemical energy into electrical energy? Yes, it is. Let's see how. We place the zinc rod in 1 molar zinc sulfate solution. Then, we place the copper rod in 1 molar copper sulfate solution. In each beaker, the reaction takes place at the interface between the metal and its salt solution, and both the oxidized and reduced forms of the same species are present. This is also known as a redox couple. A redox couple is defined as a combination of the oxidized and reduced forms of the same substance taking part in a redox reaction. Now, we connect the two solutions by using a salt bridge. A salt bridge is a U-tube filled with potassium chloride or ammonium nitrate, usually solidified by boiling with agar and later cooling to a jelly-like substance. It is an inert electrolyte and is a substance whose ions neither take part in a redox reaction nor do react with the solutions in the two beakers. Next, we connect the two ends of a voltmeter to zinc and copper electrodes by means of wires. When the switch is in the off position, no reaction takes place and current does not flow. As soon as the switch is in the on position, current flows and the reading in the voltmeter changes, indicating that current is passing through it. The current is caused due to the chemical reaction taking place between the two beakers. Since zinc is a more active metal than copper, it loses electrons and gets oxidized. The equation for this reaction can be expressed as zinc atom loses 2 electrons to form zinc ions. The electrons move through the voltmeter wire and reach the copper rod. When the electrons lost by zinc reach the copper rod, they combine with the copper 2 plus ions to form neutral copper atoms, which get deposited on the copper rod. The equation for this reaction can be expressed as copper 2 plus ions gain 2 electrons and form copper metal. As the reaction continues, the excess zinc ions accumulate around the zinc rod in the zinc solution. Due to this, any further oxidation of zinc stops as the repulsion among Zn2 plus ions increases. Similarly, copper 2 plus ions reduce to copper atoms and deposit on the copper rod. This loss of copper ions from the copper sulfate solution creates an excess of negative sulfate ions in the solution. This prevents the further reduction of copper ions. As a result, the overall reaction stops and also the current in the setup stops. To avoid such a situation, the salt bridge plays an active role. The positive potassium ions move from the salt bridge into the copper solution, thereby neutralizing the negative charge. On the other hand, the negative chloride ions move from the salt bridge into the zinc solution and neutralize the positive charge. Thus, reaction goes on continuously till the solutions get exhausted. The reaction stops when either the zinc rod or the copper ions are depleted. The overall equation for the reaction is copper 2 ions react with zinc metal to form zinc 2 plus ions and copper. Note that Zn loses electrons and undergoes oxidation, and hence the beaker in which zinc rod is immersed in zinc sulfate solution is called oxidation half cell. The electrode at which oxidation takes place is called anode. On the other hand, the beaker in which copper rod is dipped in copper sulfate solution, reduction of copper ions is taking place and is referred to as reduction half cell. The electrode at which reduction takes place is called cathode. During the cell notation, a slash is used to separate the oxidized form and the reduced form in a couple. The overall cell is represented by writing oxidation half cell on the left-hand side and reduction half cell on the right-hand side, both separated by two vertical lines. Electrons produced at anode due to oxidation of zinc travel through the external circuit to cathode, where they reduce copper ions. Note that the current flow is in the opposite direction to the electron flow. In this experiment, the two redox couples are zinc and zinc 2 plus ions and copper 2 plus ions and copper. The apparatus set up for this experiment is known as a galvanic cell. The galvanic cell was invented by an Italian anatomist, Luigi Galvani. Note that there are many factors that determine the amount of electric current produced by a galvanic cell. The most important factor is the tendency of a metal to lose electrons. Between the two electrodes, one has a tendency to lose electrons, while the other has a tendency to gain electrons. The potential of any electrode, commonly known as electrode potential, is the potential difference between it and the electrolyte surrounding the electrode. The electrode potential of an electrode depends on the nature of the metal, concentration of the ions, and the temperature of an electrolyte. If the concentration of each species taking part in the electrode reaction is taken as unity and temperature is taken as 298 Kelvin, then The potential of each electrode is known as the standard electrode potential and is represented as E0. By convention, the standard electrode potential of hydrogen electrode is taken as 0. Chemists have created a table that lists the tendency of various substances to lose electrons in a galvanic cell. Note that the values of standard electrode potentials are relative to the standard hydrogen electrode. A metal with a higher standard reduction potential can be easily reduced, and hence is a better oxidizing agent. For example, fluorine has a standard electrode potential of plus 2.87 volts, while lithium has a standard potential of minus 3.05 volts. Thus, fluorine reduces easily and is the strongest oxidizing agent. On the other hand, lithium undergoes oxidation as is the strongest reducing agent.